From Rutherford's model, what was the size of the atom? Negatively charged electrons revolving around the nucleus. And finally, Bohr's atom model could not explain Zeeman effect and Stark effect. Centripetal force should be equal to the gravitational force, angular momentum of an electron is quantized. Hello students, let us continue our discussion on the chapter atoms, where previously we have studied J. Thomson's model of an atom as well as Rutherford's atom model, where exclusively we saw all the postulates, all the points of Rutherford's model was accepted except for the fact it could not satisfy the classical theory of electromagnetic radiations, which stated that any accelerated charged particle should lose energy continuously in the form of radiations. Thereby, electrons being charged particles which revolve continuously around the nucleus should get accelerated, lose all of their energy, deviate from the orbits, and finally fall into the nucleus, which means to say matter cannot exist. And that went completely wrong with Rutherford's atom model, as well as it could not explain a few features of the hydrogen atom. Now, someone else had to take up the show. Someone else had to modify the clumps or the flaw in Rutherford's model, and that was taken over by Niels Bohr. And therefore, in my today's class, we will completely discuss Bohr's atom model, the features, the postulates, and the significance of Bohr's atom model. We will also then understand, is there any limitation with the model? Please to understand, this is a 3-mark question that is frequently asked in the exam. The first postulate. The first postulate of Bohr's atom model was a necessary requisite to modify and correct Rutherford's atom model. Now, even Niels Bohr says that an atom is spherical in shape. No doubt about the shape of the atom. From Rutherford's model, what was the size of the atom? 10 power minus 10 meter. So an atom is spherical in shape, whereas at the center it consists of a positively charged nucleus. There is a positively charged nucleus present at the center. So very clearly the postulate says an atom consists of positively charged nucleus. Why the nucleus is positively charged, we will discuss in the next chapter. I told my discussion gravitates only with respect to electrons. So please to understand, at the center of the atom there is a positively charged nucleus, and there are negatively charged electrons which revolves around the nucleus in circular orbits. So the negatively charged electrons revolves around the nucleus in circular orbits. Now, the content with respect to Rutherford and Bohr's about the structure of the atom is the same. Atom being spherical in shape, at the center existence of positively charged nucleus, negatively charged electrons revolving round the nucleus. But the main thing that has to be justified was why these electrons, in spite of getting accelerated, in spite of losing energy, why don't they fall into the nucleus? Follow carefully, students. When we say a balance is achieved, or when I say an equilibrium is established, two forces have to equate each other. See, when I am balancing myself on the floor, my weight should be equal to the gravitational force. Only then I can stand on the floor. If the planets have to revolve around the sun, centripetal force should be equal to the gravitational force. Therefore, if the electrons have to balance themselves around the nucleus, two forces have to equate. Which are they? I told nucleus is positively charged. Electrons are negatively charged. So what is the force between them? Electrostatic force of attraction. Since nucleus being positively charged, electrons being negatively charged, there is an electrostatic force of attraction, and electrons move in circular orbits. When there is circular motion, there has to be centripetal force, which means for the electrons to move balanced around the nucleus, the electrostatic force should be equal to the centripetal force. So this is the major reason why the electrons don't fall into the nucleus. The reason being the centripetal force, circular motion ಇದೆ, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. The centripetal force acting on the electrons is equal to the electrostatic force of attraction between the nucleus and the electron. So very beautifully, Niels Bohr is giving a justification for the classical theory of radiations. I do 4 derivations next, where each derivation will use this condition. Please to remember, electrostatic force of attraction is equal to the centripetal force acting on the electrons. Now, the second postulate, the nature of the orbits in which the electrons revolve. Niels Bohr says the electrons revolve in certain selected circular orbits. The shape of the orbits is circular in nature, which he calls non-radiating or stationary orbits. Very beautiful term. The electrons revolve in selected circular orbits, and these orbits are called non-radiating or stationary. ಅದರ ಅರ್ಥ ಏನು? ಆ ಆರ್ಬಿಟಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇರುತ್ತಾ? ಯಾಕೆ ನಾನ್ ರೇಡಿಯೇಟಿಂಗ್ ಅಂತ ಕರಿತೀವಿ? What is the significance of the word stationary orbit? Please to understand, students, as long as the electron is moving in this particular orbit, it will not lose any energy, or it will not radiate any energy. So please to understand, as long as the electron is present in a circular orbit, it doesn't radiate energy. It doesn't lose energy. Therefore, that orbit is called non-radiating or stationary orbits. So it doesn't mean to say that in that orbit the electron is at rest. No, very clearly the electron does not radiate energy as long as it is present in an orbit. So according to Niels Bohr, the shape of the orbit in which the electron revolves is circular. These orbits are termed to be non-radiating or stationary. Reason being, until and unless The electron is present in that orbit. Electron keeps on revolving in that orbit. It does not lose any energy. It does not radiate any energy. Hence, it is a non-radiating orbit or stationary orbit. Coming to the third postulate on Bohr's theory. Students, this is the soul of the atomic structure which is described by Niels Bohr. Slightly absurd to understand, but yes, we have to make a conscious effort to follow this, where we say the angular momentum of an electron. I am very much specific about the angular momentum of an electron in the so-called stationary orbit is quantized. You studied quantization of electric charges. Here it is quantization of angular momentum. Angular momentum of an electron is quantized, and it can take up only integer values of something called NH divided by 2 pi. Now, recall the definition of angular momentum, system of particles. It is defined as product of M, V, R. This is angular momentum of an electron. So mass of the electron, velocity of the electron in that circular orbit, radius of the electron, that puts together to be called angular momentum of an electron. In any orbit can take only integer values of NH by 2 pi. Right hand side is a constant, where H is something what we call as the Planck's constant. And what should be the value of N? It is 1, 2, 3, etc. Andre, why angular momentum of an electron is taking those integer values? Because orbit number is always an integer. Ground state, first energy level, N is equal to 1. Next energy level, you don't call 1.3, 1.4 or 1.5. It is an integer. It is 2. Next energy level 3. Therefore, in those energy levels which are integers, angular momentum should be an integer, should be quantized. Therefore, angular momentum of an electron in any selected orbit is quantized, and it takes up only integer values of NH by 2 pi. Therefore, we write MVR is NH by 2 pi. Second postulate says, yes, as long as the electron is in a particular circular orbit, it will not radiate or lose energy. Then when will it radiate energy? An atom radiates energy only when an electron jumps from higher energy level E2 to lower energy level E1. Liberation of energy, radiating energy happens when there is transition of electrons, jumping of electrons from where to where? Higher energy level to lower energy level. And therefore we say energy of a photon is h nu. H is Planck's constant. Nu, frequency of radiations. Here, E2 minus E1 equals h nu, or nu is E2 minus E1 by h, and this is called Bohr's frequency condition. Therefore, going back to the postulates, why electron is stably moving around the nucleus? Fe is Fc. Electrostatic force is equal to centripetal force. The circular orbits in which the electron moves, they are non-radiating as long as the electron is in that particular orbit. No energy is radiated. Angular momentum of an electron is quantized. It has to take only integer values. It has to be an integral multiple of LH by 2 pi, and finally there is some loss of energy only when an electron jumps from higher energy level to lower energy level. This structure of an atom, this model of an atom given by Niels Bohr was accepted to a certain level, but it also had flaws, limitations, and that is what we study as limitations of Bohr's atom model. This theory could explain only the spectrum of hydrogen and hydrogen-like atoms, where you have few number of electrons, less number of electrons. The theory holds good. But what about complex spectra, radioactive elements like uranium, polonium, radium, where there are more number of electrons? Bohr's model is not accountable. Therefore, we say it explains only the spectrum of hydrogen and hydrogen-like atoms, atoms similar to hydrogen with less number of electrons. This theory failed to explain intensity of spectral lines. Which line in the hydrogen spectrum is brighter? Which has more intensity? Which has less intensity? No. The existence of spectral lines is explained in this model, but intensity, brightness of those lines, no. This theory failed to explain fine structure of spectral lines. When I have a spectral lines, I can also see the splitting of spectral lines, division of spectral lines. Why? Could not be explained. And finally, Bohr's atom model could not explain Zeeman effect and Stark effect. So dear students, in today's class, we have studied the postulates of Bohr's atom model and also its limitations. Next, I come up with classical expressions on orbital radius and orbital velocity. Until then, have a nice time.